Suppose we're interested in calculating the integral of cosine to the 5th power of x dx. So what's the approach here? How do we use substitution to solve this integral? First of all, break this guy down into the integral of cosine to the 4th of x times cosine x dx. Cosine squared of x, let me write it here, from pre-calculus, cosine squared of x can be written as 1 minus sine squared of x. So cosine to the 4th of x is 1 minus sine squared of x to the 2nd power. So this integral can be written as the integral of, well, here you have 1 minus sine squared of x to the 2nd power times cosine x dx. When we write it this way, you can easily use the method of substitution. U sub. In the U sub method, take U to be the quantity that is actually inside your parentheses. U is equal to sine of x. Then du becomes cosine x dx, which is already there. So this is your du, and then the integral becomes the integral of 1 minus u squared to the 2nd power du, which we already know how to deal with, right? From algebra, remember that. If you have 1 minus u squared to the 2nd power, you can write it as 1 minus u squared times 1 minus u squared, or it's just the multiplication of binomials. 1 times 1, and then 1 times negative u squared, do the same thing for negative u squared as well. You get 1 minus u squared plus u to the 4th, or 1 minus 2u squared plus u to the 4th. So your integral is now the integral of 1 minus 2u squared plus u to the 4th du. Remember that the integral of, from calculus, the integral of u to the n du is u to n plus 1 divided by n plus 1 plus constant of integration. So this integral in turns is equal to u minus 2/3 u to the 3rd plus 1/5 u to the 5th plus constant of integration. But what is u? Remember that your u is sine of x, so you have to substitute this guy back here. This integral is sine x minus 2/3 sine to the 3rd of x plus 1/5 sine to the 5th of x plus constant of integration. So we see that we have an odd exponent for cosine. Now that you have odd exponent for cosine, you can divide it up into an even exponent times cosine itself. Then use the technique, the method that you learned in pre-calculus, and calculate this integral a little bit easier.